starting in chapter 10 until the rest of the text, we're really changing our focus a little bit from the endogenic processes to the exogenic processes. And for each of these weeks, when we talk about landslides, river systems, wind processes, coastal processes, you're really going to be able to focus on the geomorphology, or how the landscapes look. And what we're going to focus on is the erosional processes and the depositional processes. So as material gets moved away from the land, what does that look like? What causes erosion, and what causes material to move from one place to another? And as it gets deposited in another place, what does that look like, and what kind of landforms are created? So we're going to have two sections this week. Chapter 10, we're going to talk first about weathering, and then we're going to move into karst landscapes and mass movements. Or we're going to move in right now. Let's go back up here. Try that. There we go. So, what are the elements that are involved in weathering? Well, weathering is kind of the decay of one element, and often breaking it down into the other elements. So rust from a tin-sided building, and what causes rust. And here's some Grecian sculptures, and what causes the decay and the erosion of that, or just the regular elements of erosion. So when we look at soil, that's one of the components. So depending on what kind of soil the landscape is created in or on, has a huge impact on the type of weathering. So we talk about the term parent rock. So is it granite? Is it limestone? Is it a clay? What is the original substrate, or the original material? And then how does that weather? How does that break down into smaller pieces? So the parent rock is often has what's called a layer of regolith, or rock that's been somewhat decayed or broken down, and there's several factors that create that decay of rock. Now the type of rock has a lot to do with this. So if you start with a rock, this is an oolitic limestone, you can see it's got a lot of holes in this. It's going to allow water to come in, and ice crystals to form, or salt crystals to form. This is much easier to erode than, say, something like marble that's been metamorphosized, and all of the pore spaces or the air spaces have been removed. So the type of bedrock is really important. Another important component of weathering is the climate. Here you see three very different climates. An alpine cold climate. The processes that work here are often ice freezing and thawing. In the desert areas, you have the processes of extreme heat, sometimes extreme cold, and often salt crystals growing. And in a tropical climate, you're going to have a lot of vegetation growth, a lot of water. So all of these elements have an impact on how material weathers. We're going to break weathering down into two components: physical weathering and chemical weathering. Chemical weathering is basically when you take a large piece of rock and you take a hammer to it and break it into smaller pieces of rock. So it's just kind of, I like to use the tooth metaphor. When you bite down on a popcorn kernel at the movie and you crack your tooth, you've kind of created a physical weathering process. But the impact of physical weathering can also increase chemical weathering. So you have this big rock, has four sides. When you break it down through the processes that cause physical decay or physical weathering, you end up with many more surfaces that can now be attacked by chemical weathering. So it's not a one-way process. So the first weathering type I want to talk a little bit about is frost wedging. And here's a nice diagram showing the top edge of a cliff. So one thing you've got going for you right here is gravity. And as things get heavy and break loose, they fall under the weight of gravity. But what makes them break loose? Well, if you blow up this little example, you can see that if you have natural cracks in the rock, water gets into those cracks, and as ice forms, ice expands. So make sure you read about frost wedging or freeze thaw in your book. The landscape from that kind of weathering creates very angular, sharp-edged rocks. And that's a classic example of physical weathering. The landscape is very angular, very brittle. There's not a lot of smoothed in freeze-thaw weathering. The second kind of weathering from physical processes called hydration. And hydration is really just the swelling and cracking. So some soils or some rock is very porous, and water can be soaked into that rock, and as it does, it swells and it causes this kind of cracking. So hydration is a physical process. One of the most, here's some examples of ground cracking. One of the most famous physical weathering areas is in Yosemite National Park, and this is a picture of Half Dome. And what happens with this kind of weathering, it's called exfoliation, or expansion. And Half Dome is a granite batholith. We talked about batholiths last term, that is underground and under a lot of pressure from the soil and the other rock on top of it. And as that expands up, it grows from expansion, and as it expands, it cracks. And I said there were angular pieces, but it does tend to crack in a smooth shape. But the pieces that crack off are often granular and angular. Here's an example. So while you have kind of that smooth subsurface, the broken off pieces themselves are very sharp and ragged. So that's another one. Another term for that is pressure release jointing. So make sure you look at those. Two other types of physical weathering can just be plant roots. So you have on the right, you look at this image, and there are roots pushing down into the rock. So once there's a small crack, the roots go in, they tend to expand and push and actually add a lot of pressure and crack the rock itself. On the left, these little plunge pools are created from rock being caught in a spin or in the water cycle and just grinding round and round and kind of swirling and creating physical weathering in that way. So chemical weathering then, if cracking your tooth on a popcorn kernel is physical weathering, chemical weathering would be actual decay or getting a cavity. And the agents of chemical weathering, the first one we want to talk about is acid rain. So when you have components in rainfall, carbonic acid creates a more acidic rainfall, and that acid rain actually just decays material. Another type of chemical weathering is the creation of rust through water, oxygen, and iron, and it creates iron oxide. Here's oxidation on the landscape. So these are old sand dunes that had a lot of oxygen and iron in the landscape, and it's turned these landscapes red. Hydrolysis is different than hydration. Hydration was just the swellings, you know, the SpongeBob picture, like a sponge. Hydrolysis is the removal of some materials through the combinations, chemical combinations. And so this is the creation of clay. So clays are created with the removal of feldspar and the creation of clay materials. So make sure you look at the different types of chemical weathering. And the last process of chemical weathering is also through plants. So plants can have two effects. They can, on the right, they can lift things up, they can crack things, but they can also create chemical reactions in their root systems and decay through acidic roots and create organic material. So make sure that you know the differences between chemical and physical weathering, and some of those processes like freeze-thaw, hydration, hydrolysis, oxidation, and exfoliation. Now, the other important aspect of any weathering is this idea of a slope. Because if you have physical weathering on a flat ground, things are going to kind of stay in place or and not have as much movement. So if you have a slope, you have a lot more transference of material from one place to another. So you may have chemical weathering happening at the top of a slope where you've got plants decaying and creating small cracks, and these cracks then open up for ice formation, and the ice formation cracks that so that eventually the frictional forces are overcome and those little rock particles fall down to the bottom of the hill. So one of the things that you want to look at when you're thinking of slope and slope movement is the shape of your slope. Another chemical weathering aspect is the development of carbonation in solution, and this will be important when we talk about the next topic, when we talk about karst. So you can have acid rain, but you can also have the removal of carbon, and this is common in limestone areas, so that if you have a landscape that was created from an old ocean bed like Florida is, as rainfall comes in contact with that limestone solution, it tends to leach the limestone out. It creates carbonation deposits, and it creates dripstones. It creates, and we'll talk about the different landscapes as a result of carbonation.